So when you're solving trig equations, there's only three possibilities for the placement of the variable x. If you take this trig equation, sine theta equals opposite over hypotenuse, x might be the angle, or x might be the opposite side, or x might be the hypotenuse. If it's the opposite, it's in the numerator, hypotenuse is in the denominator. So depending on where x is determines how you finish solving the equation. So let's do these three and see how the different placement of x determines how we finish the question. So in this first one, here's the angle. Across from the angle is opposite. Across from the right angle is hypotenuse. If you remember SOHCAHTOA, opposite and hypotenuse, OH, that's sine. So we're going to use the sine equation. So I'll be using this equation here. Sine theta equals opposite over hypotenuse. Theta is the angle, so that's x in this one, equals opposite is 12, and hypotenuse is 25. When x is the angle, we've already seen this before. When you're looking for the angle, you do the arc function. So we'll do the arc sine. That's the sine -1 of 12/25. Whatever this fraction is, take the arc sine of that. When you punch that in, second sine gives you the sine -1, 12 over 25, and that ends up being about 28.7 degrees. So when the angle is x, do the arc sine or the arc cosine, or whichever. On this one, across from the angle is opposite. Across from the right angle is hypotenuse. So I'm still using sine. Sine of theta equals opposite over hypotenuse. Theta this time is 25 degrees. Opposite is x. Hypotenuse is 12. This time x is the numerator. This is x divided by 12. And just like in any equation, when x is divided by the number, you multiply both sides by that number. So 12 times the sine of 25 equals 12 times x over 12. These 12s cancel, which is what we wanted. And we just have 12 sine 25 over here. Now punch it in. Don't punch anything in until the last step here. When you punch in 12 sine of 25 degrees, you get about 5.04. So if we're doing nearest tenth, we'll do 5.0. Identify the sides, determine whether you're using sine, cosine, or tangent, and substitute in. So when x is the numerator, multiply both sides by the denominator. For this last one, across from the angle is opposite. Across from the right angle is hypotenuse. Opposite and hypotenuse is sine. All of these use sine. So sine of theta equals opposite over hypotenuse. Theta is 25 degrees here. Opposite is 12, and hypotenuse is x. Now it's a little bit tricky sometimes when x is the denominator, but not really. If you just think of this, 10 divided by 5 is 2. And if I switch places here, 10 divided by 2 is 5. Both of these are correct. So whenever x is in the denominator, just trade it with whatever is on the opposite side and just switch places. That way x is now over here, and you just punch this in to find out what it equals. So back to our equation, since x is the denominator, I'm going to trade it with the whole side, not just the 25, but the whole thing, sine of 25. So the x is now on the left. Sine of 25 is the new denominator. And now I'll punch that in. 12 divided by sine of 25 is approximately 28.4. So when x is the denominator, trade it with the other side. When x is the numerator, multiply both sides by the denominator. And when x is the angle, do the arc sign. Sometimes we have story problems. And in a story problem, there's a right triangle created because there's a horizontal distance, a vertical distance, and a diagonal distance, which gives us a right triangle. And we have two types of angles here. One is an angle of elevation, which is the angle between the line of sight and a horizontal when the observer looks upward. So you've got the horizontal, you're looking upward, and there's your angle of elevation that's created right here. The opposite of that is the angle of depression. That's the angle between the line of sight and a horizontal when an observer looks downward. So if you're looking downward, the angle of depression is created here. So whatever the story problem may be, you might have an angle of depression or an angle of elevation. And one thing to notice is that whether it's an angle of depression or an angle of elevation, those two angles are congruent because they're alternate interior angles. So oftentimes you'll find it to be easier to move it to the angle of elevation because maybe your right triangle is more obvious down here. So it's almost it's easier almost all the time to move it to the angle of elevation because you got a vertical, maybe that's a wall, and maybe this is some horizontal distance and this is a ladder leaning up against a wall. That makes more sense sometimes than thinking of a horizontal looking downward. So angle of depression and angle of elevation, they're congruent. Get your right triangle, and you'll still have, if we're in this picture, this is our angle, here's our opposite side, there's our right angle, so this is our hypotenuse, this would be our adjacent, and you'll still set up a trig function and work it that way. Let's do a few more questions now. Solving for sides and angles in a right triangle. Find x and round to the nearest tenth. This is x. That's our angle. Across from that is opposite. Across from the right angle is hypotenuse. And the leg next to the angle is adjacent. I'm only dealing with opposite and adjacent. And if you remember SOHCAHTOA, opposite and adjacent, opposite, adjacent, so we will be using tangent. Tangent theta equals opposite and adjacent. Remember, identify the sides, opposite, adjacent, and hypotenuse, then decide if you're sine, cosine, or tangent, and then substitute in. So now we'll substitute in. Theta is x, opposite is 23, and adjacent's 11. When x is the angle, do the arc. Arc tangent. So we'll do arc tangent of 23 over 11. When you punch that in, you get about 64.4 degrees. And that makes sense. That's about a 64-degree angle. Make sure that your answer is realistic, because if it's not, you might have made a mistake. Maybe you did tangent instead of arctangent, or maybe you were in radians instead of degrees. Always be in degrees. For this one, here's another triangle. We've got our angle. Across from that angle is opposite. Across from the right angle is hypotenuse. And the leg next to the angle is adjacent. I'm dealing with opposite and hypotenuse this time. SOHCAHTOA, opposite and hypotenuse, that's sine. I'll be using sine this time. Sine of theta equals opposite over hypotenuse. Now substitute in. Theta is x. Opposite's 9, and hypotenuse is 29. When x is the angle, do the arc. We'll do the arc sine, that's your sine -1 of 9 over 29. And now that the x is by itself, we'll punch it in. Arc sine of 9 over 29 is about 18.1 degrees. And that's pretty realistic. That's a pretty small angle, about 18 degrees. So identify opposite, adjacent, and hypotenuse, or use sine, cosine, or tangent. Write the equation, substitute in, and solve. When you're looking for the angle, do the arc sine. And this last one, let's identify the sides. There's a 41-degree angle. Across from that's opposite. Across from the right angle is the hypotenuse. And the leg next to the angle is adjacent. SOHCAHTOA. I'm using adjacent and hypotenuse, so I'll be doing cosine this time. Cosine of theta equals adjacent over hypotenuse. Substitute in. Theta is 41 degrees. Adjacent is x. Hypotenuse is 32. And when x is the numerator, that's x divided by 32. We'll multiply both sides by 32. So 32 times cosine 41 and 32 times x over 32. Those 32's cancel. 32 times cosine 41 degrees is x, and now we can punch that in. And x is about 24.2. So if the hypotenuse, which is the longest side, is 32, then x is 24.2. That's a reasonable answer. So when you're doing trig, look at your right triangle. Identify the opposite, adjacent, and hypotenuse. Determine whether you're using sine, cosine, or tangent. Write the equation, substitute in, and solve.